All right, welcome to lesson 8.2.1, investigating a parabola. All right, here's what your job is here, okay? As you know, there's the company called Functions of America. Congratulations, your work at the line factory was so successful that the small local company grew into a national corporation called Functions of America. Recently, your company has had some growing pains, and your new boss has turned to your team for help. See the memo below. Here's the memo from your boss. Miss Fredera Function. I have heard that while lines are very popular, there is a new craze in Europe to have nonlinear designs. I recently visited Paris and Milan and discovered that we are behind the times. Please investigate a new function called a parabola. I'd like a full report at the end of the day today with any information your team can give me about its shape and the equation. Spare no detail. I'd like to know everything you can tell me about the rule for the parabola and how it affects the shape. I also would like to know any special points on the parabola or any pattern that exists in the table. Remember, the company is only as good as the employees. I need you to uncover the secrets that our competitors do not know. Sincerely, Miss Function. So here's your task. You're not going to be doing this as a group. You can do this as an individual. You can do this on graph paper. You don't need to make a poster. However, using color and putting dots on important points and different things would be very useful. So you're going to choose one of these, actually two of these parabolas, and actually you're not going to choose. I'm going to tell you which ones you're going to be doing. In fact, let me do that right now. Boys. If you're a boy, you're going to graph this parabola right here, and you will graph this parabola right here. So the very first one, the second one here on this line, y equals x squared minus 4x plus 5 for boys, and also boys, y equals negative x squared plus 2x minus 1. So the boys are doing these two. The girls, you're doing these two, right? Opposite of those, which is y equals x squared minus 2x plus 1. So that's the first one for the girls, and the second one, girls, is y equals x squared plus 5x plus 1. You may want to make an xy table for these to help you graph these, or at least get you started on this. How far to make them? I don't know. You'll need to do them until you can clearly see the parabola of this. So now, here's what should be labeled on your small posters or on your graph paper. Does your parabola have symmetry? Symmetry, remember, is if you take your paper and fold it, the one side would look exactly the same as the other side. In fact, let me give you examples, and I'll come right back to this, of what symmetry looks like. Symmetry is here. For a heart, the line of symmetry would be here. The one side looks exactly the same as the other. For this shape, you could have symmetry going this way or this way. The parabolas that you're going to be doing will not have that many points. Lots of lines of symmetry here, and a few different lines of symmetry, or two different lines of symmetry here. So yours will look more like they'll only have one line of symmetry for the ones that you are doing today. So what is the line of symmetry? And then we're going to talk about that in class. Next, can you find what's called the vertex? And that would be the highest point that your parabola reaches or the lowest point your parabola reaches. So what is the vertex? And basically it's where it stops going one direction, it starts heading another direction is kind of what we think of as the vertex. Next part, are there any special points on your parabola? What I mean by this are, what are the points of the, where does it intercept the x-axis and where does it intercept the y-axis? And can you gain any clues for where they intercept that based on your equations here? Look for those. See if you can figure out anything with that. And then, how would you describe the shape of your parabola? For example, would you describe your parabola as pointing up, or is it pointing down? Do the sides of the parabola ever go straight up and down, vertically? And why is it? And is there anything else special about your shape? Just anything you might notice, please let us know. This is your job. Again, boys, you're doing this one. Girls, you're doing this. Boys, you're doing this one and this one. And girls, you're doing this one here and this one down here. We will see you tomorrow with your wonderful graphs of all of these. Have a good night. Bye-bye.